Hello dear students, today we will study the potentiometer. Potentiometer is a device used to measure the electromotive force and internal resistance of a given cell. It measures the potential difference between 2 points more accurate than that with a voltmeter because it works on the null deflection method irrespective of the resistance of potentiometer wire. Next we take construction. Figure 1 represents a potentiometer having a 5 meter long wire connected between points A and B. A potentiometer consists of a long metal wire, this shown in figure. Potentiometer consists of a long metal wire A to B, shown in figure, of uniform cross section area and with large value of temperature coefficient of resistance. The wire is fitted on a wooden frame which is provided with a meter scale. The wire has several segments of 1 meter length stretched on the frame. These thick lines represent the metal strips having negligible resistance. A constant current is supplied between two ends of the wire with the help of accumulator, which is lead acid cell. When key is closed, then constant current I flows through the wire. Generally, the potentiometer wire is 10 meter long. This diagram shows a potentiometer of length of potentiometer having 5 meter long wire. 1 meter, 2 meter, 3 meter, 4 meter, 5 meters. Now we take the principle of potentiometer. If rho is the resistance per unit length of potentiometer wire, then the resistance of an arbitrary length LAC means of this length from A to C will be R is equal to resistance per unit length into length, that is rho into LA to C. Therefore, potential difference between points A and C will be VAC is equal to I into RAC, which is I into rho into LAC from this relation. So we get VA to C is directly proportional to LA to C because I and rho are constants. Because rho and I are constants. Thus, VA to C is directly proportional. LA to C is the principle of potentiometer. That is the potential difference across length L of potentiometer wire is directly proportional to this length L. Next we take the determination of internal resistance of a given cell with potentiometer. Figure 2 represents the experimental arrangement for the determination of internal resistance of given cell. Suppose E is the EMF of given cell and small r is its internal resistance. This is potentiometer having wire, uniform wire AP, in which constant current is passed with the help of accumulator. This is K. At first, point B is connected to K, and by sliding the or by putting the jockey at different points on this wire, we find out the null deflection in the galvanometer. If L1 is the distance corresponding to the null deflection of galvanometer, then EMF E of cell will be directly proportional to L1, and therefore E will be equal to K into L1, equation 1. Now point C is also connected to the K, and we find the balance point L2 corresponding to the potential terminal potential difference VAB of the cell. If L2 is the balance length in this case, then VAB is directly proportional to L2, that is VAB is equal to K into L2, equation 2. Equation 1 upon 2 gives L1 upon L2, which gives VAB is equal to E L2 upon L1. Suppose this is equation 3. We know that terminal PD of a cell, potential difference of a cell, is given by VAB is equal to E upon R plus R into R, where R is the resistance connected across the cell with the help of resistance box. This is equation 4. Equating equations 3 and 4, we get E upon R plus R into R is equal to E L2 upon L1. E gets cancelled. By cross multiplication, we get L1R is equal to L2R plus L2 small r, which gives L2 small r is equal to L1R minus L2R. R taken common, it can be written as L1 minus L2 into R. Therefore, we get internal resistance R as R times L1 minus L2 upon this L2, or internal resistance of cell R will be equal to, small r will be equal to capital R L1 upon L2 minus 1. Using this relation, equation 5, we can find the internal resistance of given cell. Next, we take the comparison of electromotive forces of two given cells with two given cells with the potentiometer. Figure 3 shows the experimental arrangement for this experiment. At first, point B is terminal B is connected to the K, and EMF E1 of first cell is balanced on the potentiometer wire by finding the null deflection in galvanometer. If L1 is the balance length in this case, then E1 is proportional to L1, which gives E1 is equal to K into L1. Suppose this is equation 1. Now B point is disconnected from K and C point is connected to K, and EMF E2 of second cell is balanced on the same potentiometer wire. If L2 is the balance length in this case, then E2 will be directly proportional to L2, which gives E2 is equal to K into L2. Equation 1 upon 2 gives L1 upon L2 is equal to, equation 1 upon 2 gives E1 upon E2 is equal to L1 upon L2. This equation 3 gives the ratio of EMF of two given cells. Now let us take two numerical problems related to the determination of internal resistance and the comparison of EMF of two cells with potentiometer. First numerical, the balance length for EMF of a cell on potentiometer wire is 75 cm. When 10 ohm resistance is connected across the cell, the new balance length becomes 50 cm. Find the internal resistance of cell. Now solution to question 1 given L1 is equal to 75 cm. This is for EMF E, and L2 is equal to 50 cm. This is balance length for terminal potential difference V AB when resistance R of 10 ohm is connected across the cell. We have to find internal resistance of cell. Now internal resistance R is given as R capital L1 upon L2 minus 1, which gives 10 into 75 upon 50 minus 1, which gives 5 ohm. So the internal resistance of the given cell is 5 ohms. The question number 2, on a potentiometer wire, balance length for a cell of EMF E1 is 75 cm and the balance length for standard cell of EMF 1.02 volt is 50 cm. Find E1. Solution to question 2. E1 upon E2 is equal to L1 upon L2, which gives E1 is equal to E2 L1 upon L2. E2 is 1.02, L1 is 75 and L2 is 50, which gives E1 as 1.53 volts.